Problem number 2, we're given a graph. So when we have a graph, we need to understand what it's telling us. So let's look at the graph. We have force on the y-axis. Okay, actually this is our force in pounds, and distance on the x-axis. Anytime we have a force distance graph, the area under the curve will give us the work done by that force over that distance. Okay, that's a key point. If we have a force time graph, that gives us impulse. We would use conservation momentum principles. But here we have force distance, area gives us work. We're given a 30-pound cart, okay, an initial velocity. We know that it travels 7 feet, so it goes to that distance right there. And it's just going a little bit faster. So this force applied over this distance, non-constant force, is making it go faster. Determine the magnitude of the force F right here. Alright, so we're going to use conservation of energy. And leave out the non-zero terms because all we have is our initial kinetic energy plus some work, as given by our graph here, is going to be a final kinetic energy. Okay, so 1/2 mass velocity squared plus, in this case, the area is going to be 1/2 mass final velocity squared. Okay, so we start plugging in our numbers. We will have 1/2 the mass, 30 pounds over 32.2 feet per second squared, and initial velocity of our 4 feet. A little hard to write with my tablet here. Okay, the area again is this area right here, all the way up to 7 feet. That's an area of a triangle, 1/2. The height is our unknown force, and the base is 7 feet. Okay, that's going to be equal to our final kinetic energy, 30 pounds, 32.2 feet per second squared, and our final velocity. Okay. Every one of these terms will have units of pounds and feet. Okay, feet squared over seconds squared, feet over seconds squared. We'll end up with just a single foot on top, and then of course pounds. And that will give us the units for F in pounds. And that's what we're trying to determine. So let's plug this into our calculator now. Again, I'm using the online calculator, but I'll use it just like your solve feature in your calculator. And the only thing I have to do is put it in quotes. So I'll have 0.5 times 30 divided by 32.2 times 4. This calculator does not have an exponentiation, so for squared I'm just going to multiply again. Okay, plus 0.5. I'll just call my unknown x times 7. Okay, that's that half of the equation. I move my other half to the same side, make it negative 0.5 times 30 divided by 32.2 times 5 squared. Okay, and that gives me 1.2 rounded off. Okay, and then again that's units of force or pounds. So my force ends up being 1.2 pounds. So it varied from 1.2 pounds down to 0, gave me an increase in velocity from 4 to 5 feet per second.